Welcome to this session. In this session, you're going to give the first example on how to find solutions to differential equation using method of Laplace transform. So let's see the problem. So the question is to use Laplace transforms to find solutions to these initial value problems. So dx dt plus x equals to 0. X at 0 is 3. And then dx dt plus x 9 equals to 9 e raised by 2t. The initial value of x at t equals to 0 is 3. So let's see how to solve this. Now, the first thing, we remember that we take Laplace transform on both sides of the differential equation. So solution to A. So note that this can be written as x prime of t plus x of t is given by 0, where prime denotes the derivative. Now, taking Laplace transform on both sides of this equation, you have Laplace transform of x prime of t plus x of t equals to Laplace transform of 0. And you see, linearity property of Laplace transform operator allows us to write this one as Laplace transform of x prime of t plus Laplace transform of x of t equals to Laplace transform of 0 is 0. Now, let capital X of t be the Laplace transform of x of t. Capital X of s be the Laplace transform of x of t. And since we know that Laplace transform of f prime of x prime of t is given by s capital X of s minus x at 0, then if I had called this one equation, say 1 becomes so where there's Laplace transform of the derivative of x, I write this s capital X of s minus x at 0, and then plus Laplace transform of x of t is capital X of s is equals to 0. Now, from the question, value of x at 0 is given as 3. So I replace that point by 3. But this is x of 0. So it's the same thing as s capital X of s minus 3 plus capital X of s equals to 0, which on collecting like terms will have s plus 1 capital X of s equals to 3. Now make capital X of s the subject. So this implies capital X of s will be 3 over s plus 1. So if I call this one equation 2, now taking inverse Laplace transform, on both sides of 3, we have the inverse Laplace transform of capital X of S will be the inverse Laplace transform of 3 over S plus 1, which is the same thing as saying inverse Laplace of this one will give us now X of t. And using Laplace transform tables, you get this one to be 3 e raised power minus t. Since this can be written as inverse Laplace transform 3 1 over s plus 1. And these are standard transform that we can read from the tables. So therefore, this will be the answer to the given initial value problem. And then the second part. So we have dx part b, dx dt plus x equals to 9 e raised power 2t, x at 0 is given by 3. Now, we write this one as x prime of t plus x of t equals to 9 e raised power 2t. And so if I call this one equation 1, then taking Laplace transform of both sides of equation 1, we get Laplace transform of derivative of x plus Laplace transform x of t equals to Laplace transform of 9 e raised power 2t. And since, okay, before we write since, so let the Laplace transform of x of t be capital X of s. Let Laplace transform of x of t be given by capital X of s. Then, if I call this one 2, 2 becomes this one will be s capital X of s minus value of x at 0. This is how we write the Laplace transform of part derivative. Then plus, this one is X of s equals to. Now, when you use your Laplace transform tables, or you can as well just from definition get the Laplace transform of this function, you'll get 9 over s minus 2. You can either use Laplace transform tables or you just directly work out this Laplace. Should be able to get this. And then in the question we are given that x at 0 is 3. So this will be s x of s minus 3 plus x s equals to 9 over s minus 2. Now collecting terms with capital X of s together, so we'll have s plus 1 capital X of s. Taking this one to the right hand side will be positive. So 9 over s minus 2 plus 3. Now this can be written as s minus 2, 9 plus 3 into s minus 2. So which implies s plus 1 times capital X of s will be now 9 plus 3s minus 6 divided by s minus 2. So on further simplification, we'll get capital X of s will be, now 9 minus 6 is 3, so it'll be 3 plus 3s over s minus 2, and then we divide through by s plus 1. Now, this, you should be able to see that the numerator can be factored as 3 into 1 plus s over s minus 2, s plus 1. We are same thing as saying 3 into s plus 1 divided by s minus 2 multiplied by s plus 1. So one bracket in the numerator and denominator will cancel out. So this bracket and this bracket, so which implies capital X of s will be 3 over s minus 2. Now, once we reach here then, next, now I'll call this one equation 3. Now taking inverse Laplace transform on 3 gives inverse Laplace transform of capital X of s would be the inverse 3 over s minus 2. And using your Laplace tables, you find out that this will give us x of t, and this will give us 3 e raised power 2t. So that is how we solve those two given problems. Thank you.